Air conditioning, third video on this 560 SL. Okay, so now I'm going to show you a pattern from a fluid driven fan clutch and what it does on the high side. Take a look at this reading right here. So we see the reading up there is 235 psi. The highest reading is 232 psi. And that looks like about 220, but I can't get it up there. 220 psi. 296 psi, 251 psi. As this engine, and you see we're going into minute number 4, and I had it running about 5 minutes before I had this hooked up. As we are running, the bimetallic little thermostat in there that controls the fluid in the fluid-driven clutch is getting warmer and warmer. And as it's getting warmer, it is starting to lock up one-to-one with the engine better, which is at idle right now. And so what you're seeing here is the high pressure going down, because even though it was, it had air blowing, but now it's stronger, it was progressively getting faster, moving more volume of cool air. And as that was happening, the electric fan started coming on less and less, and now it doesn't even come on at all, because now the fluid-driven clutch has taken over, like it should have. Like other vehicles should have, but sometimes don't in my other videos. And I tell you about that. And you don't notice it because it blows really good. Everyone goes, oh yeah, it's good. The engine's not overheating. I'm going to say this 1,000 and 10,000 more times. A bad thermal fan clutch that's just okay and it has some blowing will not affect the coolant engine temperature. It will affect the amount of air that cools their fins. They have no leadway. They don't have any buffer, overbuild. They don't have a wide ballpark margin. There's very little margin for AC condensers. They put a big margin of error in radiators because they don't want a car coming back under warranty. And you can see this pattern here. Check that out. And now we're got down to the temperature where we're cycling the clutch. And you can see that right here. 36 psi down to 10 psi. 36 psi down to 9.8 psi. 9.8 psi. Now let's get over to temperature. Take a look at temperature. We're cycling off at let's focus. That's more important. Okay, focus. 39 psi up to 46 psi. 39 psi, 46, 39, 46, 39, 46. You see how you see that little motion going on there? That's the low side, that's the clutch kicking on and off. Our ambient 60 degrees is being taken right here. Let's go back to our superheat. We have to, now we're cycling, so we cannot get an accurate superheat or subcooling while we're cycling. It would be nicer if it was a 90-degree day and we would not cycle because we would have a full load over the vehicle. And something is, okay, yeah, we got to get it down a little bit here. Where am I taking up? Oh, well, I can't get a good superheat because I'm actually at the suction line, but I have radiant heat coming from the exhaust. I'm actually touching the exhaust manifold. I might burn the handle. And then I have convection heat. I have 180 degree, 160 degree heat running over. So this is not true. This is actually lower. I would have to wrap that in a rag. You put a rag around your sensor, and then you put aluminum foil around your sensor with the reflective side facing outwards, and you'd get a true temperature. That superheat, I believe, would be more somewhere down 13 to 18 on this particular vehicle. And why do I know this? 1,000 times of doing it. And the difference between doing it, not having hot, not being by a radiant, but I can't get that clamp over anywhere here. I can't get that clamp over this wide piece because it's too thick mass. And this is warm, this is gasoline. This is petrol coming from the fuel tank going through a subcooler. So this is a subcooler right here. So part of the energy here is cooler than here because part of the coolness is being absorbed. Oh, that was backwards. Part of the heat is being absorbed into the coolness of the gas, and it's a little warmer here than here. So your true subcooling out of your evaporator is here, not here where I got it, but that's the only way I could get it. What else? Okay, so I'm taking my subcooling over here. Did I say subcooling or superheat over there? I can't remember if I reversed it or not. But you guys look at the video, tell me where I made my mistake. Normally, I would take the subcooling right here, but I can't because this is painted. Unless I take off the paint, these clamps don't work on painted devices. It has to be direct metal to metal. I have to have the other non-contact clamps to go over painted surfaces. And it's off right now. And so we're getting down to what we're getting down to 30, what was that? Okay, oh yeah, and this is a fixed piston compressor. So let's give it some RPMs and see how it, Bismarck Auto Body. God, he has to call me right now. Okay, usually I always answer. Sorry, Bismarck, you gotta wait a minute. Because I don't want to retake another video and or ad, and we're done here. And I just canceled this. Okay, get out of the way. All right, yeah, my work is supposed to be taking phone calls or more important than making videos, but I just want to finish this because I want to get the hell out of here. I got so much more work to do. Let's give this some RPMs. So there's the RPMs. I looked at 14,000 miles. Let's get up to around 1,500 RPMs. Wow, that's a responsive engine. Okay, I gotta call off because he's calling me 2 times. Sorry guys, money first before videos.